So in today's video, I intend to provide a quick response. Maybe not quick. I intend to provide a quick answer to a particular question that was raised by one of our friends on this channel. And that was towards a particular video I made about a few months ago, speaking about ACID properties for databases. I'd advise you to take a look at that video so you can just understand the background of what we're talking about here. And the question is, can a non-relational database be transactional? Well, as you know, in this channel, we do not give, or I, for one, do not give straightforward answers. And when I mean straightforward answers, I mean we like to dig into stuff, dig into all of the concepts that surrounds a particular subject matter. All right, so we're able to give holistic answers rather than just giving a straightforward, because technology evolves, right? Whichever answer you're giving today can be obsolete tomorrow, and that's why you cannot just give a straightforward answers to questions like this. And even as a back-end engineer, you shouldn't be looking for straightforward answers. It is your duty to understand the technology. It is your duty to understand how they actually work. Um, so you are able to take the active role while building or working with these tools rather than just consuming or just using whatever you find. All right. So that's the question we're going to be answering today. How about we dive right in? Before we even talk about non-relational databases, I think we should piggyback into how the whole thing started, right? And why non-relational databases actually came into being. All right. Non-relational databases just came into being about a decade and a few years ago. All right. But relational databases have always been in vogue. All right. Relational databases has always been the thing. All right. So your database is fixed, not flexible. The database has a particular schema it follows, and the database is used to keep structured data, right? And obviously in rows and column. It was a groundbreaking technology, all right. But the problem that quickly began to, and it's just what it is. And for me, I think that's why I love technology, is the fact that it is constantly moving. All right, there would always be, to every problem that is solved, there would always be another subtle problem that shows up, and we just keep building until it gets better. You cannot necessarily finish solving all of the problem. Something would surely come up, and you'd have to think of better approach to solve that problem. All right, so the problem with relational databases are basically the fact that it is not flexible, it is unable to keep unstructured data. And in a world that is fast evolving, where you have things like IoT, you have things like self-driving cars, you have things like everything is basically intelligent now. You have smart TVs, smart refrigerators, smart air condition. For devices like that, you need to be able to store unstructured data. These are data that do not necessarily have schema, right? For example, your heat sensor. Your heat sensor just basically wants to send heat counts. And your IoT device basically just wants to send numbers, right? So these are data that are very unstructured, and but this wasn't available for relational databases. It has to be structured, it has to contain a schema, it has to follow all of those rules, and that quickly became a problem. Secondly, relational databases are difficult to scale. All right. And when I'm talking about being difficult to scale, you might say, but it is very possible to scale relational databases. Well, yeah, it depends on what you call scale. All right. So you probably want to differentiate between replication and partitioning. All right, when it comes to distributed system, that you are replicating a database doesn't mean it's highly scalable. All you're just doing is you're creating a duplicate of the database. It's different from being able to actually shard the database and it is available within different clusters. That's actually what it means to be highly scalable in the case of database. But it doesn't mean replication is also not a concept. When it comes to read heavy application, relational database still works fine because all you need to do is basically to just have a particular master node, right? And that master is going to be taking care of all your writes and maybe you read. And you have different read replicas across board. And obviously you have your sync mechanism, right? So because your application is read heavy, say applications like Medium, like Instagram and the likes, where you consume a lot of content, right? You can have the requests directed to your read replicas, right? So yeah, in that case, it is easier to scale. But when your application is actually write heavy, it becomes very difficult, right? Because of the data integrity and the references across board, the indexes, the schemas, and the likes. It is difficult to maintain all of those concepts across different nodes. For relational databases, they would usually scale up that scale vertically, right? And that basically means you're adding power to the machine, or you're adding memory to the machine, or you're just beefing up the machine. So these are the two problems that came into the ecosystem of relational databases. And that was why the concept of non-relational databases came into play. And notice that because of the strict nature of relational databases, it is very easy to do transaction, all right? Because obviously relational database possesses the ACID properties, all right? So it is easy to do transaction because you are not dealing with multiple databases. You are dealing with just a single machine. Every reference, every index, every schema is within that single machine, all right? So transaction comes by default. That is not an argument. All right. But with every technology, right, when you make a particular decision, you'd also have to trade off certain goodies. It's just the way it works. All right. So it is now left for you to pick out the things that you actually need and do away with the things that you think you can forfeit or you can trade off. So, in the case of non relational databases, they said, okay, we're going to make this database unstructured. We're going to make this database possess the ability to keep unstructured data. And we are also going to make this database highly distributed by default. All right, it's going to be a distributed database by default. But what this then mean is transaction is going to be forfeited, right? It is not going to be natural for this database to be able to do transaction like relational database will do. Because for a database to be transactional, it has to be able to adhere to the ACID properties completely. So in that case, your atomicity, isolation, consistency, durability, and the likes is forfeited. That was how non-relational databases came into play. All right. So it's just simply the game of trade-off, and it's simply the game of what exactly do you need? What do you want to achieve? All right. If your system is trying to keep unstructured data, or you want to be flexible about your data and the likes, and you need it to be highly distributed, right? You might have to forfeit asset properties or transaction in that regard. As I said, technology keeps evolving. You can say non-relational databases are not transactional, all right, until you check out MongoDB. Currently, MongoDB actually supports single document transaction, that's transaction within a particular document, and multiple document transaction has been sup- has been added as a feature. So the answer is yes, transaction does not come naturally to non-relational databases because of the structure or the path they have chosen to follow, right? Natural transaction becomes a trade-off for non-relational databases as opposed to relational databases. Because of the way relational database is structured, is wired, it is natural for transaction to be a feature or a part of it. But for non-relational databases, support for transaction has to be a thing that has to be well thought of, and maybe a feature that has to be researched and added. And of course, I assume it's going to be pretty difficult, right? But it's what it is. Currently, MongoDB supports it. So I'm sure before you know it, every other non-relational database would support transaction as well. So yeah, and this is the reason why you cannot get a yes or no answers with questions like this. It just depends on how you say it. I think it's a good thing about technology, that ability to keep pushing the bounds of what you call possibility or impossibility, right? All right, guys. That will be the end for today. I hope you learned a lot.